Welcome to Math 30-1. We are beginning Unit 1, Transformations and Functions. So we're going to start looking at horizontal and vertical translations. To do that, we're going to work with the function absolute value. So y is f of x, and our f of x is equal to the absolute value of x. Remember that the absolute value of x is equal to, and this is a split function, so it's equal to x when you have an x value that's greater than or equal to 0. So if x is equal to 10, then the absolute value of x just is 10. We just get x back. But we get negative x when our x value is less than 0. So if my x is equal to negative 10, that's less than 0, our absolute value of x is no longer just the x value we put in, it's the negative x value. So it's the negative of negative 10, or the opposite of negative 10, which is 10. So what happens is that we're constantly pulling out of an absolute value a positive value. So let's look at this on a table of values. So I'm just going to create my table of values here. We'll start, and I need to put a column in for x and a column in for f of x, so that we can define what our function looks like, or what its value is. So we have x and f of x. We're going to set ourselves x values of negative 3, negative 2, negative 1, 0, 1, and 2. And our absolute values are our f of x. So if I throw a negative 3 into there, I come out with the positive value, I get 3. Throw in a negative 2, come out with 2, and so on. We are always pulling out the positive value, regardless of the value, the sign of the value that goes in. So if we were to graph this, we will get a distinctive absolute value shape of a graph, and if you haven't seen that before, you'll get to see that right now. We'll create a Cartesian plane here, and when we go to graph, we've got negative 3 for our x value, and our y value here is f of x, which is positive 3, so we're going up 3, and we have our point here. Then we have negative 2 and 2, negative 1 and 1. We get 0 and 0, 1 and 1, 2 and 2, and 3 and 3. And you can see that we get this very distinctive V shape. And that is the shape of the absolute value function, f of x. Okay, so we've defined the function that we're going to look at. Now we need to look at a translation. And our first example of a translation is y is equal to f of x plus k. And in this case, we're going to make that the absolute value of x plus 3. So f of x plus 3. And we'll create a new column for that. And so we'll look at that, and we'll do this in red so we can distinguish it. So we're taking f of x. Oops, and I forgot to put my brackets in there, so we'll correct that. We take f of x and we add 3 to it. So if I take my f of x, which is 3, and I add 3 to it, I'm going to get 6. I take f of x of 2, that gives me, add 3 gives me 5, and so on. 0 plus 3 is 3, and I get 1 and 2 here, so that's 4 and 5. Oops, 4 and 5. Okay, so if we graph this, we essentially have our graph here. It looks like this, and you can take the time to graph those points more carefully so that you can see that the -3 and the 6 produces this point here. Oops. And the -2 and the 5, the -1 and the 4, 0 and 3, and so on. But this is f of x plus 3. So we can see that we've got what we call a vertical translation of 3 units. So if we take our function, add 3 to it, it shifts it up 3. So now we're going to look at another vertical translation, and we're just going to go y is equal to f of x minus k. In this case, we're going to take the absolute value of x and we'll subtract 3 from it. So f of x minus 3. So I start with my f of x. I'll do this in blue. We have 3. And then if I subtract 3 from that, I get 0. Take my 2, subtract 3 from it, I get -1. Take my 1, subtract 3 from it, get -2. 0 subtract 3 is 0, and 1 subtract 3 is -2. 2 subtract 3 gives us -1. And so we graph the point -3 and 0, x and y, remember. So -3 and 0, -2 and -1, -1 and 2, -2, and 0 and 3, and we again get this very distinctive absolute value shape, only now it's been vertically translated down 3 units. So this is f of x minus 3. And you have to excuse, I'm not sure if you can hear my dog in the background there barking away, but she's got a nice ferocious bark. So we can see that if we take a function and we add units to it, it shifts up. Take a function and subtracts units from it, it shifts down.